like 1 hour or 2 hours more. Okay, so let's see. Given the following, so now I've started recording anyway. Given the following security A and B of Aloy PLC, we have security A and security B. So when the economy is booming, you have this data, 50%, you can get return, 30% normal when economy is normal. When you are in recession, you get 5%. So calculate the expected returns of the individual asset. Calculate the expected returns of the individual asset. B, calculate the standard deviation of the individual asset. So remember, you calculate them separately first. You can't just you need those data before you calculate those things separately first of all. I will tell you why you have to do that separately. Okay. Then the third one is calculate the expected return of the portfolio. So it is when you are without A and B, you cannot do C. If you don't know, without A, you can't do C. Okay. A is a prerequisite for C. Now, calculate the standard deviation of the portfolio consisting of 60% in A and 40% in investment in B. If the coefficient of A is 0.7, okay? If the coefficient is 0.7. So that's the questions that we have. So solution. Let me check. Is my listing active? Okay, it is active. So solution now. So let's calculate the expected returns now. So for the expected return, that is very straightforward. So we'll do for asset, it's called security A. We'll do for security A first, then we'll now do security B. So for security A, what's our expected return? Expected return is ER, okay? This is not what I type of Benny. Expected return is E into bracket, capital letter R. So this is how you write it. So your expected return, now you multiply this, your economic possible returns by respective probability. So for security A, it's going to be 0.5. Please call it for me now so that I know that you guys are with me. You know, this is a revision. We've done it already in the class. I'm just doing a revision with us now. Times 0.3. Oh yeah, please call it. Second one is 0.3
0.3
times
times 0.5
05 times what? 0.2. This is for security A. Now, for security B, our expected return is going to be for security B, that's 0.5 times 0.6. Abi? Yeah. Plus 0.7 times 0.3 plus 0.8 times 0.1. So can you guys give me the answer? Fast. I'm not with my solution here. I'm just solving it. So let's hope we don't make mistake. Plus this one is 0.05 times 0.2. I got 0.31. Hope I'm correct for this one. So for the second one, 0.5 times 0.6 plus 0.7 times 0.3 plus 0.8 times 0.1. This one I got 0.59. So this is how they will be allocating mark to this thing one by one. So now we are done with this one now. Bam. We are done with this. So who does not understand this? I won't call it a simple test, simple step. Well, who doesn't understand what we have done? In case you don't know, please speak. This is not classroom. This is our family meeting. If it is not clear, I can always go back and explain 1 million times. Okay? Is there someone that does not understand what we have done now? Okay? So if there is no comment, let me move on to B. B part state that we should calculate the standard deviation of the individual asset. That's B, standard deviation of the individual asset. Standard deviation of the individual asset. That is the next thing that we are doing now. So I'm going to start with the asset A. Okay, for asset A now, possible returns, or I'll call it, let me just use PR, possible return. Okay, then you have your probability. So let's pick it now. For asset A, we have 50, 30, 5. So that's going to be that's going to be 0 0.5, 0 0.3, and 0 0.05 for asset A. Then what's the probability attached? 0 0.3, 0 0.5, and 0 0.2. So we have 0 0.3, 0 0.5, and 0 0.2. I hope I'm correct. So this is the probability that is attached now. Now, the next thing is we're supposed to calculate the ECR, expected returns. Okay, expected return. That step, Prof missed that step actually in the class. And if you miss this step, it might give you problem. You may not know how those figures will arrive at. So let's do it here. So what's the expected return? Just multiply these two by each other. So 0.5 times 0.3 is what? This is 0.15. Okay. The second one, 0.3 times 0.5. Prof didn't show us these particular steps, but which I think is necessary. This is also 0.15. Then the third one is 0.05 times 0.2. This one is 0.01. So you will add up this, add it up. Total will equal to what we got the other time. 15 plus 0.15 plus 0.01. That's 0.31. So 0.31. So this is our answer. Now, the next thing you do is that whatever you have gotten as your expected return, you have to subtract it. You have to subtract your possible return from your expected return. So you use possible return. I'll call it PR. Hello. This possible return, I'll call it PR. Then you will now say summation. I'll call it ER. So please don't make mistake. You know what you have here is what you have here. Insert. Let me insert the symbol. Let me insert the symbol. I'm looking for more symbol. I'm looking for this. Okay, this is the summation. Please, summation of ER. Summation of ER. There is a background voice somewhere, please. I don't know who is the person. So we have, so you will subtract this from this. Okay. So what we are saying is that this PR we have here, possible return, you subtract it from this total here. So give me your answer. If you subtract now, what do you have? It will be 0.5 minus, somebody gave me the answer before. What is it? 0.5 minus 0.31 minus 0.31. That's 0.19, Abi.
Yes.
Please. The second one is 0.3 minus 0.31. This one is negative what? Negative 0.01. Yeah. Then the third one is what?
Negative 0.26.
Negative 0.26. So this is what we have as our this thing. Now, the final step is whatever you've got as your PR here, you will square this answer. You multiply it by 2. Then you will now calculate the probability. You will now multiply by the probability. Let me do it now for you. So this is it. Whatever you have here, okay? Whatever you have here, you raise it up by 2. Where is the sign? Raise to power 2. Raise to power what? 2. Then when you raise it to power 2, after you have raised it to power 2, where is this thing? Where is this thing? Multiply by your probability. Okay, so let's do it now. So it will be 0.19 raised to power 2 times raised to power 2 multiply by, what's the probability? 0.3 is the probability, Abi, times 0.3. What is the answer? The answer should be 0.01083. Please, who doesn't okay, let me use Fumi's method now. I'm going to call anybody to do this math for me randomly. Let me call, this name is new here. Omolola, can you give me the calculation for the second variables? Please unmute and give me the answer, please, Omolola. Just, if you don't have calculator, just tell me what to do and I will be doing it for you.
Okay.
Hello, can you tell me what to do?
Minus 0.01 raised to power 2
Okay.
times 0.3.
Is it 0.3? It's the probability.
0.5.
Can you? Okay. Do you understand why I use 0.5, Abby? Don't just. Do you understand? Yeah, it is the probability multiplied by probability. Thank God it's clarified to you now. Okay. So the answer is what? 0. How many zero? I think like this, Abby. Or one more is still there, Abby. Abby? Something like this. Is that correct? Then the last one will be 0.26 raised to power 2 times 0.2. Answer is 0.13.
Hello, sorry. If it's 40, then it's supposed to be 5 after 0, not 1.
Is it like this?
Because it's what I'm having here is 0.0040 before 5, then 0 again.
So what I'm having,
It's supposed to
yeah,
be 5 is raised to power minus 5. So it's supposed to be all the zeros, including the decimal point, should be 5 in number. That's
Is it like this?
0.0000. Yes, but the last number
Yes,
should
and
be
then
5, not 1.
not
5,
one.
not 1.
Okay. Okay,
Yes.
like this. Okay.
Yes.
Thank you. All right, give me the total, please. I got 0.244. This is what I got. Am I correct?
No.
This should be the answer now.
0.023.
Yes,
No,
it's
it's
correct.
244.
You're correct.
I'm correct.
You're correct. That's
I'm
the answer.
correct.
0.024.
244.
So what you have, this 0.244, your variance is equal to 0.0244. Then standard deviation is equal to, you are going to square root of, let me look for that symbol. Thank God that I am resolving this thing now. So some people are still not getting some things right. So now I believe we are all getting it now. So by the time we solve the past question,
It's 0.0244, not 0.0222. The variance.
is 0. Okay, I understand. I will do it. I will do it. Thank you. 0.0244. So you will now square it. If you square it, what do you have? Square it, tell me the answer.
Is this square it or root it?
I mean, root it. You root it, square root.
Okay.
Square root.
0.1562.
Correct. So we are done with asset A. Now we repeat the same process for asset B. So for asset B now, me, I want to behave like Odogu. I will not speak. So you guys will just be, oh, you people will be checking your book. Oh. You'll be checking your notebook. Because it was class question. But let's see how it goes. We have 0.5, 0.7, and 0.8. Probability is 0.6, 0.3, 0.1. So what is the expected return? Just multiply it. 0.5 times 0.6. This is 0.3. This is 0.3. 0.7 times 0.3. This is 0.21. 21. Abi? Then 0.8 times 0.1. This is 0.08. 0.08, Abi? So that's just what we have. So that's what we have. That is what we have. So now the next thing is this. You total these ones together. So let's total this. So this, if you total it, it will be summation of the expected return. It will be summation of what? Expected return. So what's the summation of the expected return? 0.3 plus 0.21 plus 0.08.
0.59.
0.59. So if you follow our formula, the next thing is that possible return, you subtract it. This is possible return, PR. You subtract it from this total of expected return. So can somebody tell me the first figure for Gauss power? Can you tell me what is the first, what if you don't have to tell me the process to follow to get the first answer? Tell me what to do, Gauss power. Fast, 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 fast.
You minus, can you hear me? You minus
Very well.
0.5 minus 0.5.
So I have minus 0.09. So I believe you guys should understand it now. So I have 0.7 minus 0.59 for the second one. That's 0.11. Okay. Then for the third one, we have 0.8 minus 0.59. So that's 0.21. Okay. So this is what we have. All right. So let me call somebody to tell me what is the procedure for this last one here. Many more. Okay, Kefi. Oh yeah, tell me, what will I do here to get this first one? Kefi, tell me, what will I do to get the first response?
Okay, you multiply this submission, the one we finished now. You square it, then you multiply it by probability.
What will I square? Tell me, give me the number and be specific
This
on the number.
0.09 times
Okay.
0.6.
No.
This 0.09. Wait, oh. Hello? Sorry.
Yeah,
Hello,
speak.
Mama. This 0.09 square times
okay.
this probability. Yeah.
Times 0.6, Abi, probability.
Yes.
Okay, you are correct. Thank you. So this is 0.00486. Okay, like this. Then 0.11 square times 0.3. That's 0.00363. Okay. The third one is 0.21 square. Okay. Times 0.1. So this is 0.00441. So this is what we have. Okay. Right. So now that we've gotten this now, let's sum them up. We need to add up everything. So if we add it up, what do we have? 0.00486 plus 0.00363 plus 0.00441. No, 0.00486 plus 0.00363 plus 0.00441. So we got 0.0129. So this is what we have. So this our answer here is the variance. So this is your variance. So your variance is 0.0129. Then the last thing is to calculate your standard deviation. What's standard deviation? Standard deviation is your variance, you square it. So you are going to root your variance. So if we root our variance is 0.0129. Our variance is 0.0129. So if we root that variance 0.0129, 0.0129. So what's the standard deviation, please? Can someone tell me?
0.1135 V6.
0.0.1136.
1136.
Yeah,
Yes.
36. Okay, 0.1136. So that's for that. Okay, so that's we are done with the standard deviation for all. So that means we are done with the big part of the question. The question is still long ago. Now, the next thing is C. Let's calculate the expected return of the portfolio. C, expected return of the portfolio. That's the next thing. C, expected return of the portfolio. Expected return of the portfolio. So that's the next thing we have to calculate now. Now, when calculating the expected return of the portfolio, it is very simple. So the expected return of the portfolio is ERP. Okay, ERP. This E is your expected, then R and P, that's return on the portfolio. So, you are told that the portfolio has a weightage of 60% for security A and 40% for security B. So whatever return that you arrived at for the individual portfolio, just divide it by the weightage. Okay, so for the portfolio, for the asset A now, okay, let me write the formula. So this one is going to be weight of A, return of A. I don't know if I'm writing this correctly. Plus, you add it with the weightage of B plus return of B. So that is what you need to do. Now, for A, the weight of A is 60%. So 60% multiply. What's the return on A? Return on A is 0.31, Abi, that was the first thing we did here. 0.31. 0.31. Then plus, what's the weightage of B? 0.4. Plus, multiply by 0.4. Multiply, what's the return on B? 0.59.
Kazim, I think
Yeah,
you're supposed to
yes, please.
specify the weight.
No.
You're supposed
When
to
you are
specify
no, this is just only the returns. We want to
It's
calculate returns.
variance
We are
by
not.
square.
Okay.
It's variance. This is just return that we are calculating. So what's the answer? Let's quickly do this because I want to take like a few seconds break to quickly connect my laptop to UPS. So it will go off soon.
Answer is
0.422.
Time 0.
0.422.
So final answer should be 0.422, Abi.
Yes.
0.422. Yeah, please give me like a minute. Need to plug my laptop to UPS. Battery is about to go off. Hello, guys. Can you guys hear me? Hello, can you hear me? I
Yes,
need
loud
you
and clear.
guys' response, please.
Loud and clear.
Yeah,
Yes, we
hopefully I
can.
should be able to. I should be able to go for another 1 hour or more. Let's see. So let's do it now. All right. So we are done with C. Please ignore that ping sound you are hearing. It's UPS. Doesn't matter. So the last thing is for us to now calculate the standard deviation of the portfolio. That's the D part. Calculate. So based on what I have done, is there somebody that does not understand this ABC part? Because one thing I noticed is that this portfolio is the way we can easily get easy mark. Oh. This was very simple for us to get our easy mark. So is there someone that does not understand what we have done so far? A, B, C. A, B, C. Who doesn't understand it? The person should please speak. If you do not understand, kindly speak now. So if no one is speaking, I will assume it is clear to everyone. So let's do the standard, which is this is the last phase, right? Standard deviation of the portfolio. Now, this is a two asset case. So let's make an attempt to write that formula. I think, how can I use my hand to write it? Is there sigma sign in Excel? Sigma. Is it there? Excel Guru, do we have sigma sign? Or I will have to draw it with my hand. Okay, I think this is it. This is not the sigma. Sigma is the other side. Please, in case you've seen it, let me know. I mean, I'm just checking out the symbol.
Wait,
Not
wait, go back. Go up, go up, go up.
I'm going up.
Yeah, keep going up. I think I saw something that you can use that is similar. Go, keep going up, keep going up.
Okay.
Yeah, more, there.
It is actually like this,
Yeah,
but it is in
wait,
the other
wait,
way.
wait.
Let's just manage this.
Can you see that row? Wait, that place where your this thing is, that one. Can you use that one?
Can we use this one, Abby? We can use it,
I
but
think
it is
No,
sigma is
there
the
is
other
this
way.
one. See this one.
Kazim, why can't
The
you use
one
that
below
last
that
one?
this one. There is one. If you count from the one you clicked now, just no to the side.
From this other one.
To the side.
Okay. The one was the third on the right, Abby.
Yeah, this is just directly below this one that
Okay.
looks like a musical sign.
Okay.
That look
I
like
picked three. Which one do you like here? Tell me which one you like out of these three. This one, which one do you like? First or the second one? There are two now. Should we use the first or second one as sigma?
the last one.
We should use the second one, Abby.
The second one is better.
Okay, so let me delete it. So
Or
our
is it
standard
possible
deviation
you
is for
rotate
two
that
as
one?
I can't rotate. So anyway, let's shall do it. Should you guys know what we are doing, Abby? So standard deviation is sigma square. This is a two asset case, right? It is two asset case. Sigma square. You do your sigma square, which is your standard deviation P. Then you are going to have subscript P too. This standard deviation, two asset case. So when you have two asset case, can we all practice the formula without looking at our book now? Okay. So we have weight subscript A. Wait, this is asset A and B. Weight subscript A. No. Subscript A.
Kazim, it doesn't have
Then
square. Standard deviation doesn't have square. I don't think it has square now, did it?
you mean it doesn't have square?
The first one you wrote.
But this was
like, so,
No, now Kazim, this one that the formula that you wrote here is the variance. The variance, the weight as square now. Then after getting the variance, you now root the variance to get the standard deviation.
To get the standard deviation. So
exactly,
let's just keep it like this, right? Let's keep it like this. So weight of A, then you bring these ones to standard this variance of A. Just let's follow let's do it of A. like this. Okay, like this. Then you now say plus. I could have just used number directly instead of writing all this thing, but it's necessary we write it. Plus this one's too, you do for B. Okay, you do the same thing for B. B. Then you now do plus 2 weight of A, weight of B. Okay, plus then you have 2 weight of A and weight of B. 2 WA, WB, WA, WB. Then you will now bring your R. This your R is your correlation, Abi. So you have your small r. It will be small r, R, A, B, R, A, B, A, B. A and B will be subscript. R, A, B. Okay, small r, A, B. Then you have your standard deviation A and standard deviation B without square now. So this is the formula. Okay, now this is the formula. So let us apply this our formula now. Our time is running fast. Let's apply this our formula. So this is the formula that we're going to use. So the next thing is for us to apply our formula. So I'll say this is equal to, we know that the weight of A is 60%, Abby. Weight of A is 60%. So it will be 60% square. Okay, this will be 0.6. 0.6 square. Then this one now, you don't need to square it again if you are going to pick your variance. You know, standard deviation is what you need there, but don't square it again, no, because we will just pick without square is your variance, but with square is standard deviation, Abi. So you don't need to square it again. You don't need to square it again. I mean, with square, sorry, let me repeat myself again. When it has square like this, that's your direct variance. When it has square, that's your direct variance. So, and we already have our direct variance. If you remember, I asked Prof yesterday, Prof that clarified that when it is square, it is variance. But when it is without square, it's an deviation. So what we're actually calculating is variance. When we now got this variance, we will now calculate our deviation. So what is the variance for asset A? The variance for asset A is this 0.0244. That is without the square. Okay, please don't let us miss that. So this one now, multiply by this. Okay, then plus weight of B. What is weight of B? 0.4 square. Plus multiply it by what is the variance for B? What is the variance for asset B? This is the variance without before you square it to get an deviation. So your variance for asset B is what? Is this. So you put it here. Okay. So this is the variance for asset B. Okay, like this. Then 2 into weight of A. So let me say 2 multiplied by weight of A is 0.6 and weight of B is 0.4. Okay, like this. Then we now have R. R is our coefficient they've given us already in the question. They said that if the correlation between A and B is 0.7, so this is your R. This correlation between A and B, that is 0.7, is your RAB. So our RAB is 0.7. Now, you will now pick, see, this is now the direct standard deviation of A and B. So this A and B, you pick their direct standard deviation, A and B. So what is that? What is standard deviation for A? That's standard deviation for A is this. It is this multiplied by standard deviation for B is what? Standard deviation for A and for asset B is this one, 0.1136. Okay, this is standard deviation for asset B. So you might think this question is simple, but all this thing, if you miss out any figure, your solution will be wrong. So let's be careful. So what is our final answer now for variance? What is our answer for variance? So can somebody quickly calculate it for us? What is our answer for the variance, please? What is our answer for the variance? So I'm doing it now. 0.6 square multiplied by 0.0244 into bracket plus open a bracket 0.4 square multiplied by 0.0129 close the bracket plus plus open a bracket 2 times 0.6 times 0.4 close the bracket open another bracket again 0.7 times 0.1562 times 0.1136 1136 close the bracket again is equal to, so I got what is the answer for this? I think I'm not correct. So can somebody please tell me the answer?
I got 0.0168.
You got 0.0168. Okay, I've seen my own mistake. So for us to get the standard deviation now, your standard deviation is what now? You will root this thing. Standard deviation is this. You will root this figure. So how much is it? Zero point one two
0.1296.
6.
Yeah.
So yeah, so we are done with yesterday's class question. So you can see we are done with everything. A, B, C, and D. We are done. Thank God for that. So we are done with this. Okay, so let's move on now. So now, second target for today, done. What's our next target for today? Solve past question on portfolio. So, and I still have a question on bonds to solve. So help us God. Probably solve past question on portfolio. So there is a past question I saw. Yeah, this one.
Kazim, sorry, I have a
Let us
question.
go ahead, sir.
Okay, I wanted to ask,
Go ahead,
for
please.
this portfolio, the one Dr. Ahmad taught us now, what should we do with it?
It's the same thing they taught us now. Although Ahmad just gave us all the formula, he gave us the dose of question. So,
Okay.
but be rest assured that I'm giving you an insider information of all questions on portfolio and bond will come from Olowe. Ojogbo will give Olowe question. Olowe is actually the primary lecturer for portfolio and bond. So the question on portfolio will come from Olowe. The question on bond will come from bond will come from both. Yeah, the question on portfolio is from Olowe 100%. I can confirm that to you. The question on bond will come partly from Ojogbo, and Olowe too will have his own to it. If you check all the past questions, bond is always many. So bond is partly the one Amma supposed to teach us. Nobody has taught those one. Number 2, 3, 4, 5. If you check your course outline, we have some topic there. 2, 3, 4, 5 that has not been touched. They are basically theory. Those are what Amma supposed to teach, which he has not taught us. So I don't know. If he's unable to teach it during the exam, that means our question will only be on 3 topics: bond, valuation, under valuation, equity and bond, then portfolio theory, and the introduction to investment. Those are the 3 topics that they will test us on. But that will not be a good news, in my opinion, because if you see the questions that Lowe have on bond, you will sweat. I rather prefer we have many
Kazim,
topics
you
so that
are
I can choose.
recording, no.
Okay.
You are recording, no. Hope you know.
Okay, I'm releasing some information, Abby. Okay, it's fine. Let's move on. Thank you for cautioning me. Let's move on. So, okay, let's move on from now. The next thing we are taking is this one. is this question now? Is this question? That's the next one we are taking now. This one. Okay, let's take this question, and probably after taking this question, maybe if we can solve one more on bond and we end it, or we could finish, we could close from here. Today is Sunday, so people still want to go and do Italawa. What do they call it? So, solution. Let's take these questions and we close from here. All right, solution. Consider a portfolio. This is a past question, so I've forgotten the year I picked it from, but it's a full 15 marks question on investment. So consider a portfolio made up of two security X and Y with the following probability distributions of return. X we have and Y we have plus their probability. So an investor, Ayo, had committed to invest 60% and 40% of its budget respectively to these securities. Assuming three scenarios. A, perfect possible correlated returns, perfect negative correlated returns, uncorrelated returns. Determine the scenario that offer Ayo the maximum risk diversification effect on his what portfolios. So Prof taught us this yesterday, but he didn't solve the question. Or should we kuku solve this question on with the last one we solved? Perfect positive, should we, or we should just solve it here? What do you guys think? Should we add these ones to the last question we solved, or we should just take it here? Please feedback fast. What do you want? What do you want? Should we just
We
take
should
it here, or we should solve it in the last question we saw?
Can
Eh?
include
You
it to
said
the last question. Include it in the last question.
okay. In the last, so that we will not solve it again. I'll be making two, Abby. Okay. Okay. That means that is where I'm going. So assuming three scenario. A. Assuming three scenario, advice on the asset, advice on the security with the maximum returns. So we have perfect positive correlation. Then we have perfect negative correlation. Then we have zero correlation. So I'm even happy like this. So this is going to be our maybe our main stuff on portfolio. So you can always refer to this video in the future to practice your portfolio. I think that's a very good one for us. Okay, so we are using these three scenarios, right? Perfect positive. So now, please note that anything that is perfect positive is equal to 0.1. What is perfect positive? Perfect positive is when both assets are moving in the same direction. Okay, when both assets are moving in the same direction, you have a shares in Zenith Bank, you have another shares in Access Bank. So if perfect correlation, perfect positive correlation means that if Access Bank shares is going up, Zenith Bank shares too will be going up. Thank God though, they don't bring our light. So please give me just like a minute. Let me quickly reconnect something I've disconnected. Just give me a minute, please. Yeah, guys, I'm back now. Let's continue. Hello, guys, are you with me?
Yes.
Thank you.
Yeah.
So let us continue now. So as I was explaining, when you say something like positive correlation, a perfect positive, that means the two investments are moving in the same direction. Like like for example, Access and Zenith Bank. So if the share price of Access is going up, that means the share price of Zenith will also be going up. So that's the meaning of perfect positive correlation. That is, both investments are moving in the same direction. So when you have a perfect positive correlation, that is a bad investment to make because you cannot diversify. When you are diversifying, diversification simply means you want to take advantage of loophole somewhere. So if both assets are moving in the same direction, that is, both of them are facing the same direction, there is no way you can diversify, right? Asset is increasing, Zenith is increasing. What do you want to do? But you can only diversify if one is going up, the other one is coming down. Then you can move from the one coming up to coming down or vice versa. So under perfect positive correlation, the diversification rule doesn't work. So the theory of portfolio itself doesn't work under positive correlation. Okay, the return will always be, the standard deviation will always be higher than the rest. You note that you will accept a project with the lowest standard deviation. That's the decision rule. You accept a project with the you only invest on the security that has the lowest standard deviation. The higher your standard deviation, that's the higher the risk factor of that your project. If your standard deviation is very high, that means your risk factor is very high. But if your standard deviation is very low, that means your risk factor is very low. So you should accept projects or invest in the portfolio that has a lower or the lowest standard deviation. Okay, so a positive perfect correlation means both assets are moving in the same direction. Then when we say perfect negative correlation, perfect means one. Perfect means one. This one will be -1. So the meaning of perfect negative correlation is that if one asset is going up, another asset will be coming down. So this is where you can diversify. Yes, you can diversify. Here, no, you cannot. Okay. So perfect negative means that is where you can diversify. You can take advantage. Okay, just like arbitrage, you can take advantage here under this perfect negative, because as one investment is going up, the another one is coming down, so you can quickly swap, you can take advantage. Then when we say zero mean no relationship or no correlation here, so there is nothing that can happen here because you are at a standpoint, you are at a standstill here. There is no relationship or no correlation. That is, both assets, here your coefficient will always be zero. Your coefficient of correlation will always be zero. So your portfolio will not be affected by either rise or fall in the value of your assets. So your portfolio will not be affected by either rise or fall in the value of your assets. That is what you have under zero correlation. So enough of all this story. Let us practicalize this now. So assuming 3 scenarios, let's advise them on which one they should take, right? Let's advise them on which portfolio we can invest, right? That's what we want to discuss now. So either should it be perfect positive, perfect negative. Now, for these things now, there are 2 formulas you can use. I discovered that one when I was practicing this morning. There are 2 formulas you can use. So let me show you. So we want to take E part now. More time is running anyway, but we can take this class to 6:30, right? So because when I'm done with this, I want to take that past question before we close up. So assuming these 3 scenarios now, that's E. Assuming these 3 scenario A. So this is the E part. So for perfect positive correlation now, Don't even waste your time here. Just copy this formula you have here. This formula you have here. This formula here, the formula for standard deviation. Copy it, paste it here. Okay, this formula, paste it here. Where you have that your correlation. Okay, you know our correlation is 0.7. They gave us. Please change it to 0.1. Change it to 1. Sorry. Change it to what? To 1. There are two formulas. This is the first one you can use. Change that into 1. Then you calculate it again. What do you have? Calculate it. What do you have? Then we will use the second formula. So you will see that we get the same answer. So 0.6 square plus, 0.0. Please, do you understand what I did? That our RAB. See, this RAB here. Just make it. Yeah, just hold on, please. This RAB, you make it 1. All of those figures are the same. Just make this RAB 1 under perfect positive. Then under perfect negative, make this RAB -1. Then under the third one, that is 0, make this RAB 0. That is all. Then there's another formula, so I will show you that also. Please, who want to speak now? Somebody wanted to speak?
Okay. Yes, I wanted to ask something.
Yeah.
Yeah, Itoro. You know that
go ahead.
this question we are solving now, is a past question, and you moved it here. But however, in the past question, you didn't show us anything like solving standard deviation and expected value. But with this formula you're putting here, it means that other question from the past question.
Okay.
With this formula that's here, it means that we have to go through the same process of solving standard deviation and the expected probability and all those things.
You are in a hurry. We've not solved. You are in a hurry. We've not solved that question. Just hold on a bit. I'm saying this is the class question that we're solving now.
Oh, okay.
Let's finish this one.
Okay.
When we finish this, we'll solve that question. Don't rush here.
Okay.
Times 0.0129. Me, I'm trying to calculate this one. Okay.
0.019
plus 0 plus 2 times 0.6 times 0.4. Let me do my own too, so that we both confirm our answer. Then it will now be 1 times 0.1562 times 0.1136. I got 0.019. Abi, is that what you got? Hello? Is that your answer?
0.019. Yeah.
194. So then what's our standard deviation? What's our standard deviation now?
0.1392.
0.13. No. 0.0194. Then 0.1392. Like this, Abi.
Yes,
Abi?
yes.
Okay. Or this is the second formula you can use for positive correlation. The formula is this. For a positive correlation, your expected your positive correlation, the formula is this. Just say your weight of A is equal to your weight of A into standard deviation of A. Sorry, let me write the formula, please. Standard deviation of A, okay, plus weight of B, standard deviation of B. That is all. If it is positive, if it is perfectly positive, do this, you'll get the same thing. Weight of A is 0.6 times standard deviation of A plus weight of B is 0.4 times standard deviation of B. Yeah, what's standard deviation of A is this. Multiply by this. Okay. Plus.
Do you know I started the voice note?
You sent it to the group, Abi?
Yes.
You sent the voice note to the group. Is it possible
chat,
for you
sorry,
to play
voice
it?
Chat.
Let's hear the. I'm
voice
sure it's
chat, sorry. Voice chat.
But you know that we are in the class now. We cannot pick it. We can't pick it voice chat. Okay. In case you pick your call now. Oh, my phone is with my daughter. Sorry, let me pick up that phone and pick. Let me pick up the phone and call him. The phone is not with me. Sorry, just give me a deal with me. Alpha, how is she now? I'm even putting the phone on speaker now. The class people can hear. They can hear you. Yeah, madam, how far? How you doing? So how is it now? How are you feeling? So, well, okay, but you are very, very okay now, Abby. Yeah, we are actually missing you, and everyone in the class, they are all missing you. They are all hearing your voice now as I'm speaking with you. So if you had told me since morning that he will be coming, I will have joined him. Yeah, but I got the information so late and it was difficult for me to cancel the class. All right. Take care of yourself, right? Take care. And wishing you a quick recovery. I will see you soon, right? Bye. Yeah. All right. Okay. That's Oluremi from the hospital. Hopefully she's doing okay now. Glory God for that. So I hope you guys can hear a few things that she said on phone. I don't know if my phone is loud enough for you guys to hear it. Okay. What's the second one? What's the second standard deviation for? Hello, guys. Can you hear me? Hello, can you hear me?
Yes, we can hear you.
Okay. So what's standard deviation for asset B? What's standard deviation for asset B? That's 0.1136. 0.11. No, what am I doing now? 1136 is for which one? Let me check asset A. I think I made a mistake. Asset A is 0.1562. Zero. Now we should do the same thing with the answer we have before. Can you guys? We should get the same thing or almost the same answer. 0.6 times 0.1562. 0.1. So, guys, which one will you prefer to use? First method or second method? Same thing. Which one do you prefer? First one. Let's talk now. Let's interact. Which one should we use, first or second one?
Second method now. That one is faster and easier. But even the first one said there's no difference. All you did was just change the one that hard.
Yes. You don't like use negative correlation. So partly negative correlation or perfectly negative correlation. This is how you go about it. So it is still okay. Let me use the long method first. This method you have here. Okay, this long method you have. Where you have one here, change it to -1. That is all. Then you change it to -1. So the same thing goes for the second formula. For formula the two to subtract. So under the second formula, or this formula, just Just change it plus to minus, then do it again. So let's quickly do it. So let's get our figure. We should get the two answers. I want to show us, so anyone you like use in the exam. So what's the answer for the first one? 0.6 squared multiplied by 0.0244 plus 0.4 squared multiplied by 0.0129, okay, plus 2 times 0.6 times 0.4, okay, raised to the power minus 1 times 0.1562 times 0.1136. I got
Do it on purpose. Punish your lips. See how you are
0.0233.
busy clearing your lips. That's punishment now.
Azim,
What
I
I
can't
got.
see your
Then the
screen.
standard deviation. My screen is
Azim,
up now. Is it only you? Sorry. Is it everyone that can't view my screen?
It's
People are not speaking. I
frozen.
want to know. Are you the only one or everybody? So I can. It is
Your
frozen.
screen
the
is
screen
frozen.
was
Frozen.
hanging earlier,
I
so
think
I
it's
can't see it as
everybody.
well.
I even had to step out. I thought it was me.
Okay. Let me stop and reshare now. I'm sorry. I apologize for that. How is it now? How is it now? Please confirm to me.
Nothing yet. Nothing yet here.
Okay. It doesn't let me know once you can see. You still cannot see it, Abby?
Yes, still same thing.
It's not showing.
Okay. Let me exit. Let me exit the call and join again. That's the last case scenario, worst case scenario. Just give me a minute. Let me exit and join.
Black Alpha.
Hear me? Hello, can you hear me? Hello?
Yes.
Okay, you can hear me, Abby?
Yes, we can hear you.
You can hear me, right? Yeah, speak now. People should speak. Yeah.
Yes, but I don't know about others.
Am I audible?
We can hear you,
Okay, if
Kazim.
one person can hear me. Thank you, thank you. I have to quickly. Network is very bad, so just let's. Oh, even this one too is very slow. Okay, sorry, I had to just swap network. Although the network that I am on now is still very slow. Okay, I hope someone can hear me now. Is my voice stable now? Hello?
Yes, but we can't see anything. Are you sharing your screen?
Okay, let me share now. I'm sorry, apologies. Network will always mess you up. Can you view my screen now?
Yes, I can see your screen.
Thank you. Thank you for that. Thank you. So let's continue from where we stopped before the network interruption. So we have done perfect positive, right? So we use either of the two methods and we got the same answer. So for the perfect negative as well, you can use these two methods. What I just did was that place where you have your array, I change it from 1 to -1. Okay. I changed it from 1 to -1. And after recalculating it, I got 0.0. So I was trying to calculate the standard deviation before the network issue. So let me do the standard deviation. So that deviation is 0.00233. So the answer is 0.0483. Now, so for these ones too, the second formula is this. The formula we use for the positive, we add up the two, right? Under perfect negative, you will subtract, okay? You will what? Subtract. So let's pick the same variables that we have. But here, instead of adding, we will subtract. So we will subtract now. So how do we subtract? So just say this will be minus. So what do you have now? It should be the same thing with this one. Whatever thing we get here must be the same with the answer. Oh yeah, fast. Who is doing it for me, please? 0.6 0.6 times 0.1562 plus minus 0.6 times 0.1562 minus 0.4 times 0.1136. So I got the same thing. 0.0483. Hello, guys. Can you hear me? Are we together?
Yes.
Okay, so we have done it now, so it is correct. We got the same answer. Okay, now let's move on to the third one, which is 0. The third one is 0. It is 0 correlation. So the third one is 0 correlation. So 0 correlation, that's the third one. So we are done with the first two. Now let's do 0 correlation. We've done perfect negative. Okay. So let's do zero correlation means no relationship. So what you will do under this 0 correlation is the same formula you have here. In fact, I still prefer the first one, because I know I'm just continuing from wherever. So the same formula you have here. So change this your RAB, which is -1 here. Change it to 0. So you automatically know that if you change your RAB to 0, that means everything here will be 0. Even everything up to this point will be 0. Abi? because you keep multiplying it by 0, Abi. So your answer will just be limited to this. It will be limited to what? This. That's 0.6 raised to power 2 multiplied by 0.0244, okay, plus 0.4 raised to power 2 multiplied by 0.0129. Okay, so I got, what did I get?
So
I got,
Kazim,
yes,
sorry.
please.
Okay. So Kazim, you're saying in essence that for a zero correlated portfolio, it's basically the expected value or the mean of that portfolio.
Yes, 0. Yes, 0.
All
So
right.
you all this one, because if you multiply everything with everything will give you 0 here. So it's only this one you're working on now.
Yes.
So your
All
standard
right.
deviation is going to be is the root of that answer. So in fact, me, I love this
Also,
first
Kazim,
method
you have
though.
stopped recording now.
Christ, God damn.
When you went out
Network.
and you came back, yeah.
So from my screen, it is continuing. Just that it ended where I stopped, and now it is continuing. It start from my press. I can see that I'm recording here. Can you see it?
Okay.
My screen is showing
Yeah, I
that.
can see it.
Yeah, it started afresh. No problem. I will upload the 2 video. No wala. It is made. I will do the work.
All right.
It will just rest me, but I will do it. Yeah, 0.01085. So what's the answer? So I got 0.104. Now, if you look at this now, let's interpret now. Which one do you think give us the lowest standard deviation? You will discover that we have the lowest. See, the first one, perfect positive, gave us standard deviation of 0.13. This one is very high, Abi. Perfect negative gave us 0.04. Now, this one gave us, third one gave us 0.1. So you discover that the best answer is actually the perfect negative, which means that you only diversify when your correlation is actually negative. Don't diversify when it is positive, and don't diversify when it is 0. Please diversify when it is perfect negative. So I hope that question is clear to everyone. I want to move on to these past questions now before we call it a day. Please, let's move on. I initially envisaged 3 hours class today. So
Kazim,
yes, please.
hello. I did not get the last
Yeah,
part though. Come over.
okay, how we solve the last part, Abi?
Yes.
What I did was I just changed that RFP to 0. And when you change RFP to 0, all the one that I call on now, if you multiply, everything will give you 0. So your answer will only be this plus this. Then when you find standard deviation, you get your answer here. Do you get it now? Hmm? Do you understand it now?
Yes. Yes.
Okay. Thank you. So let's solve these past questions and we call it a day. So yeah, consider a portfolio made up of 2 security X and Y with the following probability distribution and returns. So an investor, Ayo, had committed to invest 60% and 40% of his budget respectively to this security. So which means that for X, Ayo want to invest 60, and for Y, Ayo want to invest 40%. So we have assuming 3 scenarios: perfect positive, perfect negative, and uncorrelated. Determine the scenarios that offer your maximum risk. So you can say that this question is more or less like a trap, but please don't enter the trap. Oh. Everything we did here, see, everything that we calculate here, you are going to calculate it again before you can get to this. You can see everything is step. Maybe we may not need to do D, Abi, but A, B, C is a must. Maybe we may not do D, but let's do everything. So you need A, B, C, D before you can calculate your E. So tell me how you will jump to E without knowing your standard deviation, without knowing your expected returns. You need all those things. So without knowing your variance, so you need it. So don't fall into trap that, oh, in fact, there is no way you can calculate it, Sha. All right, so let's do it now, fast. So we have
We will not
assets.
calculate C now. Sorry, we will not
Eh,
calculate C.
we may not calculate C. I agree with you. That's why I said that we may not calculate C, but the others are important, Abi. Okay, now let's do it now. So first thing we'll do is this. We'll calculate the expected return of the asset X, asset Y. asset X, asset Y. So for asset X, 18.5, that would be 0.185. Okay, 0.15 and 0.25. Then what's the probability? They gave us the same probability. 0.35 is the probability, 0.35, 0.4, and 0.25. So we need to calculate our expected return. So can you guys help me, please? Help me. This is for assets X. Help me with the expected return. So I will say 0.185 times 0.35. So the answer is 0.06475. Okay. Hello, are you with me? Hope network has not messed me up again.
No,
We
we
have
can hear you.
Okay, this is 0.06. Then this one is 0.0625. Now, so if I'm to add up everything now, my expected return is going to be how much? 0.06475 plus 0.06 plus 0.0625. 0.18725. 0.18725. Okay, so that's for this. Then what's going to be the next one? The next one is your probability. No, your possible return minus your expected. So this one is going to be 0.185 minus 0.18725. Okay, I got minus 0.00225. Okay, then this one will be 0.15 minus 0.18725. This gives me minus 0.03725. Okay, then the third one is 0.25 minus 0.18725. This one gives me 0.06275. So the third one, I believe we all know how to calculate the third one, Abi, so that I should just continue solving it, right? We all know how to calculate the third one. So it will just be square, you square it and multiply it by the probability. So this will be 0.00225 raised to power 2 multiplied by probability times 0.00225. Please also calculate, so in case I made mistake, times 0.35. So I got 0.12345, 12345, 1772. Let me stop here. 1772. So long. Okay. Then this one will be 0.03725. 0.03725 raised to power 2. Okay. Times 0.4. This one too is 0.000555. Okay. Please, guys, calculate to help me, so that in case I make mistake, you can correct me. 0.0625. 0.06275 raised to power 2. Multiplied by 0.25. I got 0.0009844. Please, are you guys with me? Am I audible? Have I made any mistakes? Everywhere is quiet. Please speak. Are you guys with me?
Yeah.
You are with me, Abby? Times. Sorry, I'm doing it again now. Okay, plus 0.123555 plus 0.1239844. So 0.0015 412. So this is the answer. This is my variance. So my variance is this. If my variance is this, what's my standard deviation? My standard deviation is, so what is it? I will just say this 0.00. I got 0.0393. Yeah. So this is for the asset X. We'll repeat the same thing. So you can see now that the expected returns is equal to 0.18725. This is the expected return, 0.18725, which is this. And this is our standard deviation. So now we will do the same thing for asset Y again. So let's do the same thing for asset Y. Asset Y. So for asset Y, give me the variables that we have. 23.5, that's 0.235. 0.235. 20%, that's 0.2. Okay. Then we have 15%, that's 0.15. Okay. So probability are the same. So let's just multiply it again. Let's multiply it again and get our answer. So what's the answer here? 0.185 times 0.35. This gives us 0.06475. Okay, 0.15 times 0.4. This gives us 0.06. Then 0.15 times 0.25. This gives us 0.0375. So like this.
Hello, Kazim.
Yes, please.
Please, I'd like you to check the under the possible return. Check the second number. Is it 0.15 or 0.20? 25.
Thank God though, that you are following me. Me, I make it rubbish a lot of me. 0.2 times 0.4. This is 0.08. Thank you. The first one is 23.5, Abby. 235.
Yes.
235. Thank you. So, well, okay. 0.235 times 0.35. That's 0.08225. So, now what's our total expected return? Plus I got 0.19975. So this is the expected return for this asset. So let's calculate we have our expected return already. Let me copy it, paste it here. Now let's do the standard deviation now. Let's do the standard deviation for the project, for the asset B itself. Okay. What was the standard deviation now? So you just do your possible return minus this expected return here. You put it here first. So we have 0.235 minus 0.19975. What do we have? 0.03525. Okay. Then the second one is 0.2 minus 0.19975. So this is 0.12325. This is what I got to 12325. Then the third one is 0.15 minus 0.19975. Okay. I got 0 minus, third one is I got minus 0.04975 minus 0.04975. So the last thing is you square this figure and multiply by probability, right? So this one square times 0.25. So this one I got 0.00061 8. No, 0, 0, 6, 1, 8, 8. 6, 1, 8, 8. Yeah. Then this one, I will do 0 0.0025. No, 0 0.00025 raised to power 2 multiplied by 0 0.025 raised to power 2 multiplied by 0.4. Eh? Ogun. Ogun. 1, 2, 3, 4, 5, 6, 7, 8, 2, 5. Yeah. Let's do the third one. 0 0.03525 raised to power 2 times 0 0.35. If somebody is in a hurry, there is no way you will not make mistake here. Here you get. If someone is rushing, there is 4, 8, 9, 7. If someone is rushing, there is no way the person will not make mistakes. So let's do it. At least let's just get the nearest. It may not be 100% accurate because of approximation, but we'll get the nearest first of all. So 0.123 434 897 plus 0. Okay. Yeah, plus 0. So I got 0.001054. 10537. So this is what I got. No, 0.00. Yeah. So this is my variance now. My variance is this. So what's my standard deviation? My standard deviation is going to be what? I will just say it's equal to
0.225.
0.3246. Yeah. So this is the answer for the asset B. For asset, this is asset X, this is Y. It's a deal. Guys, do you know what I did? I made a mistake. Solution. I was typing on asset X instead of Y. Shit. Okay. I think this is what we did for asset X, right? Let's see what we can. Let's see how we can salvage this. I've made a blunder actually. I was typing on the other one instead of typing on the. This one here is asset Y. This is asset Y. Oh. 0. Okay, we can quickly correct it now. 0. This is asset Y. So I will just quickly do some little amendment for the asset X. This is asset Y. Then this one is asset X. So let's see what we can correct there. Yeah, so let's quickly. So asset Y is correct now. Even though we've done X2, but I made a mistake. I went to type on it. So this is asset Y. Then for asset X, let me quickly replace the figure. 18.5, 0.185. Don't worry, I'll quickly do it. So 0.15. Then this one is 0.25. Yeah. Then probability is this. So I think all the figures should still be same. 0.35 times 0.185. Yes, figures are still correct. I've not changed the figure. Yeah, it's correct. I've not changed the figure, so this is correct.
Yeah,
so
it's correct. It's correct.
Our expected return is correct. It's correct. I've not changed the figure. So this is my expected return is correct. Then I think this one too is correct, Abby. Right? This variance too is correct.
Yes, the variance is correct. 0.00154.
So let's just do the new standard deviation now. What's the standard deviation for it?
Standard deviation of X is 0.0392.
like this, 0.0392. So we have all
Yes.
our vitals now, asset A, asset B. So they no send us to do any direct. We can calculate the return of the portfolio, but they no send us. Let's just move on to what they send us to do, right? Under positive, negative, and this other ones too. So let's do for positive, what's it called? What did they say? They say positive, perfect positive correlated returns, Abi. Assuming a perfect positive correlated returns. So let me steal my formula here. Assuming a perfect positive correlated return. So we'll say perfect positive correlated return. So what is the weight of the investment? Is it 60-40? What is the weight? They said it is 60-40, Abi.
Yes.
So
Yes.
should we use the second formula, or let's just use the second formula straight away, Abi? No time, Abi. Let's just use the second
Yes, we can.
formula. So then we multiply by the standard deviation, Abi. What standard deviation for this one? Standard deviation for the second one is 0.03. This one is this. Okay. Then this one, first one is what? 0.0392. 0.03. So what's the answer for this, please? What is the answer, please? I have 0.6 times 0.0392 plus 0.4 times 0.03246. 0.03246. So the answer is 0.0365. 0.0365. So that's the answer for perfect positive. Now, what about perfect negative? Is perfect positive is +1. Perfect negative is what? We'll just subtract the two. Same thing. Perfect negative. So it will be -1. Okay, -1. So the same thing you have here. Instead of adding up, subtract. Okay, the same thing you have. Instead of adding up, just subtract. So this is 0.6 multiplied by 0.0392 minus this. You would subtract here. So what do we have? 0.6 times 0.0392. Okay. Minus what? 0.4. Sorry. Please help me with the figure if you have it now. Minus 0.4 times 0.03246. I got 0.0105. Okay.
54.
54. Yeah,
Yes.
like this, Abby. So
Yes.
this is what, yeah, so this is it, Abby. All right, so the last one is 0. Let's do for 0. For 0 now. For 0. So 0 correlation. So it would be weight of A standard square or something. Hold on now. So it is that formula that we'll pick directly now. For 0 would be weight of A square plus this square. This is the formula. So weight of A square plus the Q of A square. No, this is subscript, so please. A is subscript. A is subscript, please. Then B is also subscript. This is subscript. So you will find, this is square. So you will find this value first. Then when you have found this value, you will now find the standard deviation. So let's do it. So this is going to be what now? It will be 0.6, 0.6. Just multiply. What is the variance of asset? No, it is XY, not A. X, X, X. This would be Y, Y. Okay. So let me change it. So let me change it. X, X. This is Y, Y. Sorry. Someone is stretching. I'm disturbing you guys too much. Abi Pele. So this is what we have, 0.6. So what is the variance for X? The variance for X is this. So you copy it, put it here. Okay. Then plus, what is weight of Y? 0.4 multiplied by, what is the variance of Y? Variance of Y is this. Oh yeah, what is our answer? So we'll do the square root of our answer. 0.6 times 0.0015412 plus what? Plus I got 0.00134. This is what I got. So the standard deviation is going to be the square root. Where is my square root sign? Square root of this. Okay. So what's the answer? 0.0366. 0.0366. 669. Let's say 67. Or 66669. So what is your decision now? What is your, now you have your decision now. They say you should advise him whether what he should do. I mean, see what they say. They say the time is another that offer the best rate. So which one do you think offer this guy the best now? So if you look at the perfect, because it's not over, you must decide though. You must perfect positive, perfect negative, zero correlation or something. So for the zero now, this is what we got for the zero. We will pick the one with the lowest. That is the one. I can assure you that it is negative that should be lowest. Then the perfect negative is this one. See my perfect negative. And see my perfect positive. My perfect positive is this. So which one is the lowest here, guys? Can you tell me the lowest? Is the perfect negative, Abby? So yeah, based on the above scenario, the perfect negative correlation will give Ayo the maximum return on investment since it has the lowest risk, lowest standard deviation. Okay. All right. So I believe when you solve this question like this, your 15 marks is in the bag. May God help you, and may God help me too. May God help all of us to be able to solve it like this, so that 15 marks, we can pocket it. Amen. So that's the end of this. Let me stop recording now. Let me stop recording. I have other informations to pass. So
sorry, Kazim.
yes, please ask me.